Hello. This week we want to start getting prepared for our final exam. You'll notice that the final exam review packet is posted, or you received a copy of that during your in-class session. So please make sure that you have the packet to look over as you kind of watch this video so that you can focus on some main topics. This video is not going to go through every problem, but it's going to pick out some major skills that we want to just review and refresh our memory on. Please keep in mind, if you have questions, take those to class or email your teacher to make sure you get those answered before final exam time. Let's go ahead and look at the packet. There we go. Make this a little bit bigger so that we can see. Okay, back in chapter 1, what we did want to start with, okay, was our notation. So please make sure to kind of review your notation for lines, rays, segments, angles, and points. Okay, always make sure that you're writing your answers with the correct notation. And at the beginning of the test, start this out well to make sure that you're using that correct notation in your problems. All right, what we want to begin with, okay, are a few problems here at the bottom of that first page. Okay, so starting with number 6, we see that we have A, B, and C are collinear. And again, you might want to just kind of draw that sketch out. If we know that, okay, A, B, and C are collinear, and B has to be in between A and C, okay, we've got them on that line in that order. We can then mark these distances. AB is x plus 16. BC is 5x plus 10. And then AC, that entire segment, is 56. So this was our segment addition postulate. We can add up two parts equal to that total and then begin to solve that. So if I wrote this as an equation, it would be x plus 16 plus 5x plus 10 equal to 56. And we can work our way to solve that. So we have 6x plus 26 is 56. If we subtract 26 from each side, we would then be left with 30. Divide by 6. And x would be equal to 5. Okay, always make sure to go back and check to see exactly what the question is wanting you to solve for. Here they want the length of BC. So BC was this segment here. So plug in your 5. So BC would equal 5 times 5 plus 10, okay, or then 35, okay, for the length of that segment. So just kind of be careful in there. In number 7, we're asked to find the midpoint, okay, the point exactly in the middle of those two. Algebraically, you do have a midpoint formula where we average our coordinates. So we would be taking -8 plus -2, which are my two x coordinates, and dividing by 2, and then -6 plus -9 divided by 2. Be very careful with negatives here. We would get -10 divided by 2, which would be -5 for the x-coordinate. And then here, -15 divided by 2 would be -15 halves. Now you do want to kind of see that that point would lie in the middle. So if we look at our values here, -5 does lie in the middle of -8 and -2. And -15 halves is -7.5, and that is in between -6 and -9. Okay, always kind of check to see that your point makes sense once that's calculated out. Okay, when you're finding the length of a segment, you can use your distance formula. But if you're given the picture of the graph, you might also use Pythagorean theorem. So I could just make this here a right triangle and use those lengths to solve that accurately. So in this case, we would just count the number of units that we're moving horizontally and vertically. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 units vertically, and 1, 2, 3, 4, 5, 6, 7 units horizontally. Okay, the length of that segment is the hypotenuse, or C, if I were to plug into Pythagorean theorem. So we've got 7 squared plus 11 squared equal to C squared. So 49 plus 121 gives me a value of 170. So solving that, C would be the square root of 170. Keep in mind your final exam is going to be multiple choice, so then you want to either convert that to a decimal or leave that as a square root, depending on the form of your choices that you have to choose from. So just kind of take a look at how that's working. Again, distance formula would be another option there, so kind of think about it that way. If you prefer to use your algebraic formula, you certainly can. All right, on the back of that first page, okay, we have an angle diagram here where we need to fill in some pieces and then solve for a missing part. So in this problem, they tell us that angle B to O to D, which is the entire angle, is 46 degrees. And BOC, part of that is 26. So we know the entire angle is 46 degrees. This part is 26, so then I should recognize that 26 plus 20 would equal 46. So the measure then of COD would be 20 degrees, and we would write it with this notation. Okay, but there's your angle addition postulate. Again, you can add two parts of an angle to equal the whole thing. All right, so more vocabulary just to kind of talk about. Lots of vocabulary that we have covered throughout this first semester. Just make sure all these terms are familiar to you. Now what we want to do with this diagram is compare everything to angle COD. Okay, so if I just kind of mark that angle on here so that you can see which one we're looking at. Okay, there's my angle COD. I would want to know an angle that lies adjacent to COD. Well, adjacent has to be right next to or share a side. So that could be angle BOC. But if you didn't see that as one of your choices, then you'd want to look on the other side to see what's connected to it. And we could see the angle DOE, okay, would also be an adjacent angle. Keep in mind there could be more than one choice, so then you want to make sure that you check to see which choice is actually in your multiple choice selection. Now, if we want to know what's complementary with COD, complementary has to make a 90-degree angle. So the angle I'd want to use here would be BOC, because these two together would make this right angle in our diagram. However, if we want it to be supplementary, keep in mind that supplementary is going to be 180 degrees or form a line. So now if I'm using this angle here, C to O to A would then create a straight line here. Or it's possible that we use D to O to E again, because that would make a line, okay, right here on your diagram. So again, more than one possible choice there, so please be careful. Okay, and then keep in mind vertical angles should look like they're directly across from each other in the diagram, and they will be congruent. One would reflect right on top of the other. So if we're looking for what's vertical to angle COD, we should say that's AOE. Okay, then always a good idea to kind of review all of your algebraic properties. These were listed in your text in chapter 2 if you want to go back and reference that or reference your notes in chapter 2. But our reflexive property is the one where it's equal to itself. Okay, so we want to see that it's exactly the same on each side. So x plus 2 equals x plus 2, okay, would be that reflexive option. Okay, if we move to the back, we've got beginning of our angle diagrams. In this angle diagram, what we should notice is that these two angles form a straight line. So I should be able to add those and make them equal to 180 degrees because they would be considered a linear pair. So my equation in this case would be 4x plus 90 plus 2x plus 72 equal to 180. Okay, simplifying here, we would get 6x, and 90 plus 72 would be 162. We'll subtract that. So 6x would be equal to 18, leaving a value of 3 for x. All right, now when we move to 30, we're looking at our special angle relationships here. And we're looking at it by position, okay, with a transversal. So if I were to look here at angle 6 and compare that with angle 3, I should notice that both of these angles are located on this transversal, okay, that's intersecting those two lines. And these angles are on the same side of the transversal in between the two lines. So we called these consecutive interior angles. And then if you remember, if our lines are parallel, then the consecutive interior angles are supplementary, okay, or have a sum of 180 degrees. Okay, but that would be the relationship there between those. Now at the bottom of this page, we're going to look at a couple of our algebra review problems. Now these are what we are going to cover when we return from Thanksgiving break, but they are Algebra 1 review type of questions. So these are probably formulas that you have worked with before. So let's kind of introduce this within this review now. The first one is finding your slope. So we should know that our slope is just the rise over the run of your line, or our formula, y2 minus y1 over x2 minus x1. So if I'm given 2 points, I can find the slope of that line. So I'm going to subtract my y coordinates first. So I'm going to take 2 minus negative 5. And then I'm going to place that over the difference of my x coordinates. So negative 3 minus negative 9. Okay, now what we should notice here is that the two negatives will make a positive, and we want to be very careful with our signs. Okay, we've got 2 plus 5, which would equal 7, and then negative 3 plus 9, which would be 6. So on the graph between these points, to get from one point to another, I'd be moving up 7 units and over 6, or to the right 6. And that would give me the slope between those points. Now, if we want to find the slope-intercept form of a line, remember, slope-intercept form is just the equation y equals mx plus b. If you're given a point that has to be included on this line, 8, 6, that can be your value that you use for x and y, because that's an x and y coordinate. And if our line needs to run parallel to this, parallel has to be at the exact same slope. So in this case, our slope, or m, is right in front of x, which would be 5. So if I wanted to find my equation, I'd want to solve for that y-intercept. So we would plug all those values in, except for b. So the y-coordinate that was given in the point was 6. the slope of that equation was 5, which will be the same as ours. The x coordinate given was 8, and then we went to solve for b. So 5 times 8 would give us a value of 40. If we were to subtract 40, 6 minus 40 is going to give us a negative 34 for that y-intercept, or b. So when I write my equation, I'm going to write it as y equals 5x, because I want the same slope, and then minus 34. And you should see then these two lines would be running parallel to each other because they're at the same slope. Okay, we're going to start to move into some of our triangle problems now. So another key idea is that the angles of a triangle always have to add up to 180 degrees. So here I notice I have a right triangle, which gives me a 90-degree angle. So then I have 73 plus x plus 90, which has to equal 180. So I can take 180 on my calculator and subtract off those two given angles, and we'd be left with a measurement of 17 degrees for that remaining angle. Okay, your two acute angles in a right triangle should be complementary, or should add up to 90 degrees, and you can see that that would work with our angle measurement. As we move down to 45, we want to identify the congruent triangles, write ourselves a congruency statement, okay, and then state why we know that those triangles are congruent. So the first thing that we did within chapter 4 was mark that diagram. And what we have left to mark on here is that shared side. So we should see that we have 3 sets of congruent sides. So our congruency case was side, 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 or SSS. So these triangles are going to end up being congruent. It's one of my cases. So now I need to write the congruency statement. So I say that triangle, let's say it's WXZ for that first one. Then we need to make sure we match up our angles. And in this case, we should see this as a reflection if we were going to map one to the other. So angle W here would be congruent to angle W on the bottom triangle. Angle X would reflect to angle Y. And then Z with Z. So when they're asking for a congruence statement, that means we're just going to have that congruent symbol in between, okay, 2 congruent figures. Okay, in 46, we want to find the true statement. So we want to find the case that does prove that the triangles are congruent. So here, I should see I have some given information marked below here. Mark it on your diagram so that you can see exactly what you have. So we have side TV congruent to WV, and UV congruent to XV. And then the one other piece of information that I can mark as evidence on here are the vertical angles in this picture. We know vertical angles are congruent. Well, then I should see that we have our case for side angle side. Now, if you look closely at your choices, you're going to notice that we had side angle side in 2 different choices. So one of them must have the congruency statement written correctly, one incorrectly. So we need to find out which one, okay, is written the correct way. So triangle TUV. Well, I know that angle T, okay, would have to rotate to angle W. U would rotate to X. And then V with V at those vertical angles. So it looks like A is written correctly. Okay, you can see that it doesn't match up right away, okay, correctly in option C, because angle T does not correspond with angle V on the other triangle. So this was not written in the correct order to match up. So always check those congruency statements and make sure they're written accurately. All right, in our figure below here, we're wanting to reflect this image and see where it goes. Well, our line y equals x. Keep in mind, our line y equals x is that positive diagonal, okay, moving perfectly through the middle, okay, of our xy coordinate plane there. So if I look at where this figure right here is going to reflect, we should see then that this segment here would flip over to this segment here, or it would then go to P, or that's labeled as P on this figure. Okay, look to see where does that flip, okay, in that picture. Okay, and then 55, this is going to be a translation here, and I'm going to move my figure x minus 4 and y plus 5. So this means it's going to move 4 units to the left and 5 units up if I look at how that coordinate rule is written. And then I want to know what the endpoints of A prime, B prime are going to be. Well, if A was at 1, 5, A prime, okay, if I just plug these coordinates in or move them, however it works for you. Okay, 1 minus 4 would take us to negative 3. And if I plug in my 5, 5 plus 5 would take you up to 10. Okay, or you see if you start at 1 and move 4 left, you'd be at negative 3. Start at 5 and go 5 up, you would be at 10. Okay, so you can kind of think of it by its movement also. But that would mean that B prime would then be at 5 minus 4, which is 1, and negative 3 plus 5, which would be 2. So there's the coordinates then of that translation. Okay, and then one of our commonly missed problems that we see on the final is solving for that scale factor. So again, just a little review here. We want to make sure we know the formula for scale factor, and we measure that dilation from the center. So C is going to be my center point on here. And the center to our image is the numerator, which will give us a value of 20. And then the center to the pre-image, make sure you're looking at this entire distance. So segment addition here tells me that that distance is 35. And then that's a fraction that can be reduced. So those both divide by 5, so then that would reduce to 4/7 for that scale factor. And we use that variable k for scale factor. All right, well, this should give you a good start to your review packet. Okay, just really take the time to start preparing yourself for final exams and kind of just continually review the content that we have been working with over the course of this semester. We're nearing the end, so make sure all assignments are complete. You get your work complete. We want your grade to be the best it can. All right, good luck this week and have a good rest of your break.